So today we're going to talk about making to manufacturing, and we have three great panelists, all coming from different backgrounds, all bringing different experiences in. I've been looking forward to this conversation for a long time. So we're going to turn it over to our panelists. I'm going to let them introduce themselves, but want to just quickly flag that we have three different folks. We have Nathan coming from SparkFun. We have Michael, who's coming from both a research perspective and is now in the startup world, actually working in software. He's made a little bit of a pivot, so we're looking forward to hearing about that. And Cara, who's a professor now at Cornell in mechanical engineering. So I'm going to turn it over to these folks to introduce themselves, and we're going to start with Nathan.
Hello, folks. My name is Nathan Seidle. I am the founder of SparkFun Electronics. I've been doing what I've been doing for about 21 years now. It's kind of wild to think that I never really had a real job other than I was a grease monkey working on motorcycles for about 2 years during college. But since that time of starting SparkFun, I've been developing products and designing circuits and giving talks about open source hardware, kind of spreading the good word about how important it is for business and innovation and for new entrepreneurs as something to consider other than sort of the intellectual property and the standard route that we were all taught in college. I'm very enthusiastic about telling you about my projects, and just like any nerd, if you ask me about what I'm working on, I'll bend your ear about all the exciting projects I'm working on. But yeah, I'm excited to talk to you today about kind of my story and how SparkFun went from very small roots, a bedroom, to where we are today, and sort of as they say, a going concern. So we're happy to be here today. Thank you very much.
Great, thanks, Nathan. Cara, I'm going to turn it over to you next.
Yeah, so I'm Cara. I'm a new assistant professor in the Sibley School of Mechanical and Aerospace Engineering. I started this past fall, and can really echo Deanna's comments about Cornell being, any person, any study, and really any person, anything that you want to build, which is really exciting and great. Can definitely echo that the resources here to assist with that are excellent, and I'm excited to leverage those during my career here at Cornell. So before I came to Cornell, I got my bachelor's degree from the University of Rhode Island as a part of the International Engineering program there. So I majored in biomedical engineering and Spanish. And this was a really unique program because I completed my undergraduate studies in 5 years, essentially inserting somewhat of a gap year into my studies so that I could go abroad and have a semester of study in this other language. So my language was Spanish. Where I was taking classes, like learning the material the way that it's taught in other places other than the US. I learned a lot about the structure of education by sort of doing this program. And then I also did a 6-month internship. So I sort of got to see how things actually work from a business side outside of the US as well. And when I came back, I was really excited about many different things, but essentially what I learned is that there's so many things that I didn't know and that I was excited about that I wanted to go to graduate school so I could keep learning. So after I finished my bachelor's, I went and I got my master's and PhD from Stanford University, where I did research focusing on robotic systems, specifically haptic systems, and really looking into wearable haptic systems. So I was doing a lot of making of these systems, trying to test with end users, work on different control schemes to really have these sort of synergize between the overarching system and the users themselves. So I got to do a lot of that, and also then do another sort of research stint abroad in Germany, where again I got to learn more about the research process from another institution. And what was really exciting and cool is to see how all these different places use all different kind of resources. And so I'll talk a little bit about that during this panel today. But I'm really excited to just talk about sort of my educational journey and how I see the future of making.
Great, thanks so much. And we'll turn it over last but not least to Michael.
Hi, everyone. My name is Michael Sugian. I'm currently a machine learning research engineer at a startup called Mobley, where our pitch is we're trying to do machine learning for machine learning. So trying to make algorithms that can speed up some of the inefficiencies and tediousness in the machine learning experimentation process. Before this, I earned my PhD from Cornell, where I research design and machine learning for human-robot interaction. And a lot of my work revolved around my robot Blossom. In the background here, you can see I'm controlling it with my phone right now. So we designed Blossom as this open source platform for other researchers and roboticists to research human-robot interaction with a low-cost platform that can be maintained and extended according to different needs. Right now, Blossom's constructed as a model kit. You've probably seen some of these where you kind of cut these out and snap them together. And that's really how I started getting into making. So I was building model kits with my dad when I was a kid. And in college, despite being a mechanical engineering major, got into electronics, buying many things from SparkFun if Nathan needs this endorsement. And even though I am in software now, I still continue to make lots of gadgets in my spare time. Some of the ones I've made recently are this digital film camera with a digital sensor in it and this weird looking robot arm behind me.
Great, thanks so much. And Nathan, you've now inspired, if we have time at the end, you might all be getting the "what are you working on" question, because I know that we all have things that we're working on and we all have exciting answers for that. But I want to turn us over now. I want to talk a little bit about this making and open source. So get a little bit into the maker movement, why the maker movement was so interesting, what the open source aspect is, and how this kind of all pieces together. And we're going to jump in to get started here with kind of a question that I want to pose to everyone. We'll go around the room around what does it mean to be a maker? When we talk about makers, especially today, 2024, what is a maker? So why don't we start off, Nathan, lead us in. What do you see as a maker today?
It's kind of a fun, weird question because humans especially, have always been makers for millennia. In terms of today's use of the word, I think it's sort of this thing that we attach to being able to find our tribe. So one of the first maker fairs I went to, whatever it was, 2007, I want to say, was this kind of transcendental experience because you go and you're hanging out, you're looking around, you're like, whoa, I found my people. I found my nerds. Like I had been on the internet, but I had never been like close to people who thought like I did. So a maker to me is the term that folks use whatever they're into. It might be electronics, but there's so many other things, whether it's making sourdough bread or cats or you name it, board games. Once you're a maker, you've sort of dived into your hobby to the point that you can find other folks like you that enjoy participating in what that is. Today, I'm sure we're going to talk about business and specifically, hardware and electronics, but the maker movement was sort of this realization that there's somebody like you out in the world. And if we can find them and form our tribe, we can make things together and we can have hobbies and we can grow in new aspects that I don't think we had an opportunity before. Maybe that was the internet. Maybe that was just society coming to grips with the fact that we're all a little different. I'm not sure what caused the maker movement, but I'm happy to be part of it. And I'm really happy to find other electronic enthusiasts and really just let's go build fun stuff. So making, I don't want to sort of couch as electronics, but the maker movement has been really exciting and been fun to watch over the last, it's been, 2-3 decades maybe, but really if we go back hundreds or thousands of years, we've been building things for a long time.
Great. I love that. I love the finding your nerds angle. That's something I need to put into my repertoire. Cara, do you have anything you want to add?
Yeah, I mean, I think that was a really great point that this is a really nuanced but really interesting question that like we have had makers for so long, right? Like I don't think that this concept of a maker is necessarily new, but I think like what makes a maker to me is the creativity and like the drive to really like find a solution or put something out there. And that solution doesn't necessarily have to be something really technical. It could even just be like artistic. Like I want to create this expression that is going to express how I feel. So it's not even just from the engineering side, although obviously here we're talking maybe more hardware and electronics focused. But it's really just people who are creative and problem solvers. That's kind of how I think of makers. It's like, what do I have around me that I can build into something that's like exciting and unique and going to do what I want it to do. And sort of to kind of comment on Nathan's thought, when did this start? Like, when did this movement begin? It's really hard to put that starting point on it, but I think it's just been with the, increase in things that are open source. So whether that's information from the internet or, the developments of 3D printers and like the costs really going down on these 3D printers, some of the work they've been doing at SparkFun, we just have like so many more resources that are accessible to people who would normally be really interested in bee makers that maybe previously were just using, screwdrivers and screws and things that they could get from a hardware store. Well, now they have access to way more than they've ever had before. So we've sort of seen this boom of, the makers movement because now we just have so much more. But I think that creativity, that spark, that drive, sort of like what Nathan was saying, has been here for a long time. So yeah.
That's great. Thanks so much. Michael, anything else?
Yeah, I think Nate and Cara said most of it. I think by definition, the word just means someone who makes. More colloquially, it's someone who makes with these tools and techniques that happen to be associated with professional engineering. So CAD, PCB software, but I think there's a lot of value in expanding or broadening this definition to sourdough or art and thinking of this as a medium in the way that writers write or painters paint and makers just make. And we want to express things and find others who share the same drive that we do and share and communicate through this medium of hardware.
I love it. Love it. Makers make. It's the end of the day. It's the simplest definition for it. All right. So let's jump in a little bit here, a little more specifically. So Nathan, you started out, developed kind of what was in some regards the beginning of open source. We had a couple of people that were starting to talk about this. So I want to hear a little bit about what your original vision was for SparkFun, how that's evolved in the last few years, maybe a little bit about SparkX, if you want to lead us into that.
Sure. It's the long and varied history. Okay, so SparkFun started in the very beginning of 2003. So in 2002, I was shoving stuff into a breadboard and was programming a microcontroller. And I had, in 2002, I had built a GPS logger. Data logger. And today it's super simple just to download an app on your phone, but you really got to transport yourself to whatever it was 22 years ago. It was hard. And to get the pieces to build that prototype, there was no online checkout. You had to contact all these various email lists and ask for folks if they had an extra, and there were no data sheets. It was madness. And to feed my own sort of hobby, I wanted to get this stuff in and build something. So I had my desk set up, and I was a sophomore in college and was building this GPS logger. And as any time we're learning something new, that's the most fun, right? We're right at the edge of our knowledge, and we're breaking through and say, is this possible? Wow, it is possible. Great. And so I was really iterating and having a lot of fun. And I moved a piece of equipment around on my desk, and I accidentally shorted that programmer against some screws and some wire on my desk. And there was a spark and a little bit of smoke, and I had fried the thing that I needed to continue my hobby. I said, oh my goodness, what am I going to do? I didn't have enough money I was on student debt to go to college, so I didn't have the money for the first programmer, let alone the second one when they were very expensive. So got on the internet, and it was atrocious. It was a really bad user experience. But the best parts came out of a place called Olimex. And Olimex is still around, and I'm still good friends with the founder's sons. Olimex is based in Bulgaria. So the best parts in the world had to come all the way from Bulgaria. So it was a difficult process, but I said, you know what, they've got the best parts. Can I make a website to sell Olimex stuff in the US? They agreed, and we put together a website. At that time, just taking pictures of the thing next to a quarter, taking a picture of the back of the board. None of that was being done. So we said, hey, let's try to be a little different. And so we made, it was me in my bedroom, but we put up a website, took pictures, began to sell things. And after a couple of years, we started to design our own boards. So those were breakout boards for accelerometers, were some of the first products. And then, continue forward to when Arduino was founded, and we started doing Arduinos. And then, all the sensors and just the cell phone market really gave us a lot of new technologies that were difficult to access. And so SparkFun kind of stepped in and developed products around those boards. So that's sort of how SparkFun started. I like to point out that if anyone listening is thinking about starting their own business, please jump in and do it. But do know that when I started SparkFun, I wrote a business plan. Everyone told me to write a business plan. And the business plan, I still have it today if anybody wants to read it, but it's terrible. It was all about how I was going to sell computer parts I thought that at the time, building your own computer was very exciting. And so I said, well, we'll do this microcontroller stuff, but we'll also sell parts to build your own computer. Well, very quickly after I started SparkFun, it was obvious nobody cared about the computer parts. Everyone cared about the microelectronics. So when you start your own business, go to where the customers are. Don't think that you have to stick to this rigid, there's no business plan that is rigid. There's no plan that should stay rigid. You really have to go with the flow once you've started your business. And so SparkFun very quickly said, wow, let's get rid of that and just, focus on these microcontrollers. And we've been growing and trying to keep up ever since. You asked about SparkX. So SparkFun, let's see, so it was SparkFun, and as you mentioned, let's see, Adafruit was next, and then Seed Studio. Competition is a very good thing. And so because of those competitors, SparkFun has really had up its game in terms of documentation and customer service and picture quality and tutorials and all the things that surround a product. Because of that, whenever we launch a new product, there's a tremendous amount of work that goes into designing and putting the documentation around those new products. It means that it slows down the development cycle because you have of all the extra bits that have to be included. And so a few years ago, I stepped down as CEO and started a group called SparkX. So what SparkX does is it throws spaghetti at the wall faster. It's a brand within SparkFun so that users who see the SparkX products realize there's little or no documentation. We'll give you a data sheet, but maybe there's no code, maybe there's no hookup guide, maybe there's no exhaustive pictures or demonstration products. But here's the thing, and we set expectations for the customer. So we say, SparkX is really that crucible. It's really the bleeding edge of whatever we're working on. But SparkX gave me the creative freedom to go and try wacky things. We've done everything from a nuclear-powered battery to atomic clocks, to keyboard kits, to all sorts of stuff. And a lot of them fail, but that's the point. We want to try to, test those things out before we spend the time and resources to really flesh out a full SparkFun product. If it's successful in SparkX, then you'll see it kind of quote unquote go red, where it'll go to the main product base. But SparkX is my happy place where we just get to sit in the corner and play with new stuff.
Love it. Love it. Always love throwing spaghetti at the wall and seeing what sticks. So that's an industry perspective. Cara, I want to switch it over then to you doing research right now. Tell me a little bit about how advancements in prototyping technology and open source technology kind of influenced your process and how it influences research.
Yeah, so I had a bunch of things that I sort of wanted to talk about in this question, and then now with things that Nathan has brought up, I think I'm going to take it a totally different direction, and actually maybe talk a little bit more about sort of my experience getting into research even. So I greatly, as Michael pointed out, benefited from many of these open source groups and communities sort of starting in that. When I went to undergrad, I had no idea what I wanted to do. I didn't know that I wanted to be an engineer. I sort of stumbled into it, and I actually almost left because things were moving maybe too slow for me, that there was so much theory, and I really had this sort of maker mentality at heart, and I felt like I couldn't actually make anything. I just knew theory and I knew concepts. And towards the end of my undergrad was really when I sort of started more having access to all these different resources, and I got to take the theory that I knew and apply it with all these different things that were cheap and easy to access. And so like from that side, I think what this open source movement and the maker movement has really enabled is now in my own research, I do a lot of outreach. So I really try to develop tools or go to specific groups and communities to introduce some of these like ideas and concepts earlier on. So when they're in high school, sometimes even when they're in middle school, to give people an idea of all the possibilities that exist. Just because I know for myself, I got lucky, I put it, that I ended up in engineering. And so because of all these different resources and how cheap and accessible they are, people have this ability to read these wonderful tutorials that SparkFun and all these other groups are putting together such that they can be doing these things at home before they get to then learn some of the more like formal and fundamental theory behind different things. So like I said, I was going to answer this slightly differently, but I think that that's a really important note to make, that this has allowed us to bring people into research earlier on. Like, I am always really impressed when I meet the freshmen that come in and they go, oh yeah, I've been programming in an Arduino and I've been doing all these things. And I'm like, that took me so long to get to that stage to be able to do that. Now I'm like, okay, cool. Like, you're already coming in with these fundamentals and this skill set that we can just build from there. So that's I think the really exciting part, is that like we're able to pull people that have this interest in earlier, or even just introduce these ideas and concepts to people who don't even know if it would be of interest to them or not. So it's kind of nice that like we have this ability to do this now. But I would say sort of the other pro and things that I've seen in research, and I know Nathan commented on this a little bit with the spaghetti against the wall, it's just we can iterate so much faster. I can order a bunch of things that come in and we can try, 10 different things within a week, versus before, you'd have to look up each part. It's hard to get everything. That now this process just goes so much quicker, that it's, I think, really exciting. I will say one thing that I have seen sort of occurring, a shift maybe in the mentality, is, well, let's just try the most complicated thing that we can try. Oftentimes people are like, oh, I have to use this microcontroller or this thing to build it up. And sometimes I say, okay, well, actually, let's start the prototyping and the making with even cheaper, easier components. So let's build this with magnets or with Velcro, or, like just use sort of these simple components to do our initial prototyping and then take it the next step. So it's sort of double-edged sword here, that, okay, great, we can do things far more complicated and much faster, and we can iterate really quickly, but also that sometimes from a research side, I say, okay, we should take a step back actually and start really with even lower cost materials to do some of this prototyping. So
Can I ask Cara a question?
Sure.
Go for it.
Do you ever experience with academics doing research what I call the engineer's curse? So there's let's say a tool that'll get the job done, but it's $5,000, right? But now that we have all of these new students that like, oh, that's just an Arduino with a relay, I can put that together this weekend, but it takes them 3 months, and it actually is way more complicated than they thought. Do you ever have an instance where the optimism sort of gets in the way of practicality?
I think sometimes. I think that's usually what's a little bit trickier for students is, it's still from an academic side. We want to keep everything as low cost as possible, right? We're charging grants and we got limited funds. And so like, yeah, this engineer's curse where you're saying, oh, well, I can just buy this one part and add it in. I think it does happen occasionally. That's my job as a PI, to try to, weigh that risk reward and keep my students from maybe going down those paths. So, thankfully I don't have too many that are coming to the top of my head right now. That happens in my lab, but I do see that this is often that trade-off between like time and money. Is something that I think I would imagine, from an industry side or a startup side, this is also something that people grapple with. Yeah.
The older I get, I want to build everything. I see these things. I'm like, why is that $30? I can build it. No, buy it for $30. It's going to save you time and money. But it's really exciting to see the lowering of development tools and equipment. And I'm a big fan of sort of the open source biomedical tool set, where these things were thousands of dollars before, and very smart folks are making them hundreds or dozens of dollars. So it's opening up a lot of doors.
Yeah, we've been doing a lot of work or looking into work that others are doing about these sensors, these wearable sensors that you can do all this kind of biomedical monitoring, things like related for telehealth. And it's so exciting to me that this is something that we're at the stage where this is possible. And like you said, these pieces of equipment would be thousands and thousands of dollars. And now we're able to sort of pull these different components together to create super low cost system. So yeah, it's very exciting.
Yeah. So I want to turn it over to Michael now. So Cara, your spin on that question was actually really relevant to what I was going to lead into with Michael here. Talk a little bit about STEM and bringing this stuff into education earlier. Michael, you had a big piece of working on Blossom that was really about access and educational inputs. So what do you feel is the value of having open source technologies as more of an educational piece?
Yeah, so I think there's this quote I keep in my head from the physicist Feynman: "What I can't create, I don't understand." So, like Cara said, just actually making something is putting that theory to practice. Reading a cookbook isn't the same thing as actually making food in the way that reading all this theory and stuff that Cara was saying that she was getting bogged down. I felt that too, which is why I drifted into electronics, because some of these large mechanical systems aren't accessible, but some of these smaller electronics are. So that's where I'll get my fix of actually making things. So during my PhD, we deployed Blossom in some educational outreach contexts. So one was through the 4-H program, where we had middle schoolers come in and they put Blossom together, they customized it, they programmed it to understand how the parts that go into a robot. And some of my collaborators in California are continuing this work with more machine learning and AI things based in it. But I think, Carol, you also mentioned how the skill set of the incoming freshmen is just so much higher than what we had access to. And I spoke with a lot of educators during grad school, and just hearing about kindergartners having access to 3D printers, or some people writing grants to get laser cutters in elementary school, it just makes me super jealous that they're getting access to this. But it's great, and it'll be really exciting to see what the kids of today will be making in a few years' time.
Yeah, actually, when I moved here to Ithaca, I just found out that the public library downtown has laser cutters and 3D printers. And I was like, this is so cool that like you can be, going on the weekend with your parents and doing all these cool things at the library. Like anyone can go to the library. So yeah, super exciting.
Yeah, it's almost frustrating now that we see it and we're like, how did we miss this? Why, it's a great evolution. We have one more question. It's related to the question that we got about from the audience here, from Keith, about maker created products and open source and how that transitions into manufacturing. And so, Nathan, I want to bounce back to you quickly to talk about open source and the relationship between making and manufacturing, and taking open source content to a more scalable model, and how that all kind of pieces together.
For years, it was very tricky. There was tutorials online from Suan and everybody else, but you don't need a couple $1 million worth of machines to build electronics, to build a product. You need those machines to build a lot of that product. So if you're just starting out and you want to throw spaghetti at the wall, you want to build 5 of a thing, 50 of a thing, you can do that in your garage, in your basement, in your bedroom, wherever you are. The tools are online, the tutorials are there. The question really is, does the market care? So we've gone from I can't build my thing to I can build my thing. Now let's see if the market cares. So I'm pretty excited now. I think a lot of folks, the tricky bit is just past that. So you've built 50 and you've realized that, yay, there is a market, but it's a market of 500 or 1,000. And then the next leap is 10,000 pieces. How do I manufacture? How do I really spin up these processes? Then we get into standard old business problems of, returns and marketing and shipping and logistics. And that's hard business to solve. Some of those sticking points I've seen come down in the last 3 or 4 years. So now it's easier than ever to say, upload a bill of materials to JLC PCB or PCBWay, or name the assembly house. And a couple weeks later, you can get 10 units of your thing soldered together. It's pretty exciting to see, and I'm excited to see sort of the flourishing of consumer-based products. We don't have to have the monolithic Samsung anymore. We can have 1,000 different Samsungs and really get the feature set that pertains to me, to my particular whatever it is. My chair, my lamp, the product in my house can be more customized to me. The consumer can really get what they need. So I'm to go from sort of that idea to market, that idea to a customer. is getting easier every day. I think the real challenge now is how do we kind of scale that up to the market size? If your product is pretty good and you've got a couple thousand customers, I feel that that is actually the kind of the hardest point, where if you need to build 500,000, we got that. If you need to build 50, cool. But that 1 or 2,000 is where I see the future being in the most sort of innovation and development.
Great. So I want to take this and we're going to roll with this for a little bit, this making to manufacturing, and want to talk a little bit about what the different angles are. And so, Cara, again, bringing in this research angle, how do you envision the bridges and the transitions between making, manufacturing, and research, and kind of the different roles they all play?
Yeah, I think this is a really intriguing question because each of these sort of areas have slightly different goals, right? So if we think of like academic research, normally we're trying to push the frontier to say like what's possible, and usually there's a solution in mind, but it's what's going to enable the next step. And so typically we're not thinking about manufacturing at all, right? We're just saying, can we make one prototype that's going to work exactly how we want it to work? And somebody else is maybe going to figure out the mass manufacturing later. And so I would say, maybe that's a generalization. Not all labs think this way, but I would say that's a fairly academic way of thinking about research and prototyping, that like, I just want to build something that's really going to push the edge here and show everyone that it's possible. And then all of these challenges that exist in manufacturing, somebody else who's going to actually start a business is going to do that. And I think in the future, this is something that has to change. And I hope, my lab is a part of making this change to say, not only we're going to build one, but we're going to build one that could be then scaled up. And whether that's scaled up to hundreds or scaled up to eventually thousands, each of those are going to pose different challenges, right? Whether it's from the type of equipment that you have accessible to do the manufacturing. But I think laying the fundamental documentation and structure such that things could be scaled up is something that I think in academic research we don't necessarily focus too much on. And I think in order to do this, we sort of need help. We need to communicate more with different people in the community that actually do the manufacturing. So I think having more of these conversations and more integration between academic research and, whether it's companies that are trying to then take some of the findings from research to actually turn it into a product, or groups like SparkFun that are saying, hey, like we want to be able to sell or distribute many different things of the things that you're developing here. How could we feasibly scale up? I think these conversations are just bound to happen, or hopefully are about to start happening. So I think it's a little bit of change in mindset from the research, academic researcher side of not just one prototype that works on any given day, but like, how do I create something that is sustainable and could be built up? But then also reaching out to say, what are the challenges that you guys are facing and seeing when you're trying to manufacture things? How could we maybe iterate our design or provide documentation to assist with that?
That's great. Thank you. And kind of on the flip side of this, so Michael, there's a lot of distinctions between manufactured and mass-produced product, and that's kind of what we're leaning towards. But there's also this big like artisanal movement as well for these types of products, right? We think about the Etsy's and these maker pieces. And so your robot Blossom was leaning more towards the artisanal side. Was there ever a goal to go to mainstream manufacturing or mass production, or what was the drive behind the artisanal piece there?
Yeah, so the artisanal aspect is one of the things that we wanted, or one of the values that we wanted to embed in the design. So when you think of robot, or you do a Google image search for robot, you get these machines that are mass manufactured. They all look alike, and there's a legion of them in a factory or something. So we wanted to question, okay, why do these on an individual level? A lot of these robots look like Apple products from the year 2000. They're white, shiny, gloss plastic. We wanted to question that, but also we wanted to question the process of robot building. What if instead of buying a commercial off-the-shelf robots, there are many great ones, but they're kind of tied to the businesses, and sometimes if the businesses are struggling, it's hard to get maintenance or repairability. Instead of working with one of those robots, what if you handcrafted a robot? What if you made a robot in the way that you'd write someone a handwritten letter, or you'd home cook someone a meal, and this kind of more personal angle towards sharing and communicating through robots as a medium. So I think the We did consider some entrepreneurship programs with manufacturing, but I think with the goal of Blossom to be an open source research platform that other researchers, primarily academic labs, can use and extend for their own applications, it's been good in that way. Other labs are continuing to use Blossom, so right now that we think that the distribution, kind of this a la carte open source method, is fine for the goal of the project.
Awesome. Awesome. So let's maybe come full circle on this. And so, Nathan, I'm going to bounce back to you. And you've touched on this a little bit already, but making to manufacturing. Is this a reasonable expectation that someone in their garage can be a hardcore maker and they can turn that into a mass producible, manufacturable product? Is that something that you see is available to the world today? What are some of the challenges and resources that might be out there?
Yeah, I believe so. And so just to give you an example, so we have lots of little boards SparkFun is known for, right? Little circuit boards with a high precision GPS receiver. And I designed this a few years ago, and it's been selling great. And lots of tutorials about how to hook this up. But if you show this to a surveyor, if you show this to someone that actually deals with high precision GPS, they're terrified. If you take a normal, when I say normal human, if you take a person in normal society, bare circuit boards kind of scare them. And so if you take plastic and you wrap that circuit board into just kind of enclose it. It doesn't have to be a good enclosure, but it's incredible how the general consumer responds when we take a normal Arduino project and we put it inside of an enclosure and we put a nice looking sticker on the top of it. It totally transforms the product. People go, oh, wow, that's, okay, yeah, sure, it's not Apple, but that's totally something that I would use. And so what we have found at SparkFun is the advent of 3D printing, specifically SLA printing. So FDM is sort of the hot glue gun, the MakerBot, whatever that everyone's used to at home. SLA is the goo printer. So that's a little more expensive, but the prints are finer. SLA is scalable. So SLA, you can print lots of enclosures for cheaper and cheaper, where FDM printing, if it takes 10 hours to print one, it's going to take 20 hours to print two. You cannot scale that. And so we found that by designing enclosures for SLA print and then putting, a couple pieces of printed plastic around our electronics, it really opens up a new world. So to answer your question, I think that entrepreneurs, people with a product idea, no longer can we just throw a printed circuit board out there. But once we wrap this in plastic and put a sticker on it, we immediately launch from a hobby or maker business into what consumers think is a professional ongoing business. And it's really easy to do that. It's really easy to design an enclosure in whatever CAD software you've got. You begin to 3D print stuff for a couple bucks an enclosure, and pretty soon you arrive at a thing that's pretty nice. It's never finished, but of course in engineering, nothing ever is. Nothing's ever finished. And so by throwing it on the internet and seeing who wants to buy one, I am very encouraged by folks creating products that I can give to my 70-year-old father, that I can give to my 6-year-old kid, and they can be successful with.
That's great. And I have to say, we use the phrase here at Cornell that hardware is software wrapped in plastic. And I'm really feeling a little bit validated to know that that escapes out into the real world, that you can just wrap it in plastic and all of a sudden it becomes this new thing. At least that's what we say in hardware quite frequently over here.
Yeah, actually, I wanted to jump in really quick before we move to the next topic. I think what Nathan just brought up here was a great example of what I was trying to relay earlier, and I don't know if it got across, but this idea of you have a FDM printer or an SLA printer, and one scales up better than the other. When I look at what we would do within the lab, these FDM printers super cheap, or you have this one thing that works well and it works cheap, and so you make one and it's sustainable, right? You can make one, you can make two, but as you build up, it's these key insights of like, oh, well, you could still make it with this, this other platform, this other way, but this, I would say, is not necessarily a way that typically academic researchers think. Right? Like you might say, oh, I have to scale it up, but what are the ways that I could scale it up? And so I think conversations like these, and anyone who's here listening to the panel, these type of insights I think are just super great. So I just wanted to, give a round of applause to Nathan for giving an excellent example of sort of how you can scale up and ways to think about scaling up, not just I have to scale up, how do I make more? It's like, oh, I can slightly change this process and now my scaling is so much easier. So sorry that I jumped in there, but I just thought that was a great example.
No, I love that. And I love the combination, that industry research crossover is something that I think, to your exact point, is really up and coming and is going to bridge a lot of gaps for us. So one of our last topics here, I want to take a quick bridge and think about what the future is and what we're excited about for the state of the art, where we're at right now, where we want to go. And so, Cara, I'm actually going to start with you again. You're working in haptics. What do you feel right now where we're at with the state of the art? What are you excited to see in the next couple of years?
Yeah, so I'll just give a little bit more background for those who are listening that don't quite know what haptics is. So haptics is a subfield of robotics that specifically focuses on touch. So you could think about haptics as incorporating touch for robotic systems, so some piece of hardware giving it the sense of touch, or it could also be creating artificial touch that then is relayed to humans. So there's sort of two ways to think about it, that it's sensing or it's actuating. And so, I think there's both a hardware perspective where there's challenges of things that we want to improve and directions that we could go. And also, because there is this human in the loop, there's really interesting questions about the neuroscience of it, us as individuals, sort of connecting a little bit with Michael's work is how do users actually interact with the systems that we build? So I think that's particularly exciting. But if I were to comment primarily on the hardware perspective, and maybe this is just from my research interests as well, but I think the future is really how can we continue to build individual components, maybe modular pieces that are now soft or flexible. Could we be having more like flexible PCBs, using textiles as a way to do the sensing, basically taking it such that, all these typical pieces, we look at these boards, they're rigid. And so if you're going to be interacting with the environment and you want to sense a touch with an object, you kind of want it to deform the same way the human finger goes. And, when you hit something, your finger pad deforms. And so going from this, traditionally fairly rigid set of components to now things that are more flexible or soft, maybe they're things that are just adapted to the environment, or maybe they're things that are being worn on an individual. So you want that to be something that's comfy. I think that this is an area where the next several years are going to continue to boom. And I think in research, this is happening. And I'm hoping this is very much going to translate to, I don't have to make custom sensors and actuators in the lab all the time. I can just go to SparkFun and buy them. And so, yeah, I'm hoping that transition happens fairly soon.
Great. So Michael, I heard some really interesting perspectives from you on this next question. And, we're talking about future of making and the future of STEM. And we think about engineering as one of these big fields. The engineering and education in this direction is like so many big prospects for the future. So I guess my question would be kind of a spin on this is, do you see engineers as makers? What do you see as the difference between someone who's like the maker, that lowercase engineer versus the capital E engineer? Do you see a difference there? And how do you see that relationship to makers?
Yeah, so I definitely don't want to gatekeep. I think anyone can be a maker. It just has to come from your internal motivation to want to see something or want to make something so badly that you take the time and the effort that it requires to see it through. I think maybe a demarcation between that lowercase e engineering and the capital E engineer could be doing it from an amateur hobbyist perspective versus someone who does it professionally as a career. And amateur has kind of this negative connotation to it, kind of connoting that someone is not good at something or shouldn't be doing something, but it comes from this word of like loving something so much that you will do it even when you don't have any expectation of getting something out of it. So I think working with just anyone who has this motivation to build anything can be a maker.
Great. And so maybe our last question for this, to go back to you, Nathan, what's something that you aspire for the future of the maker movement or the world of making?
Ooh.
Big question.
Yeah.
Big question at the end of this topic.
There's to we can point our creative efforts towards hobbies and things we enjoy. And believe me, I wholly believe in that. And my evening projects are things that I enjoy doing. However, I hope that the future of making leads to something outside of ourselves. For example, I like to volunteer at a local kids museum. And I've been doing it for 10 years. And to do engineering is hard. To do engineering in space is incredibly difficult. To do engineering at a kids museum is sort of in between. It's really, really hard to build something to withstand an onslaught of 5-year-olds. So what I would like to encourage folks is explore, develop yourself, but also find a way to use those skills to better society. And I know that's a tall ask, but the idea of adaptive technologies or we have the skills to make life a little bit better for other folks, not just ourselves. And so by contributing sort of some of those hobby hours to society, I think can improve things as a whole. So I'm pretty bullish about the future of STEM. Everything we've talked about today, the technologies, we're really standing on the shoulders of the people before us. It started with, I don't know, Ada Lovelace and Babbage and the compiler, and you fast forward to now we've got Arduino. We've got, we were talking before the meeting about how kids are coming in from middle school already knowing Arduino and how to play with electronics. So incredible, they're ahead of me. So it's how can we build tools to allow the next generation of makers to stand on our shoulders and not have to go through the same pains that we did. So I'm excited about the tool makers and the folks in the future that are going to really, it's changing so quickly, but I'm pretty happy to see where we're at and where we're headed in terms of future developments, just to make it easier to make and then have a positive impact on the world.
I love that. I love that. So we're coming up on the end of our hour already. So we have a couple of questions towards the very end here that I think are really kind of intrinsic to this topic of making and manufacturing. So we've kind of heard this in a couple of different flavors already, that making is this internal drive. It's this thing that we have to do, that humans have been doing forever. And whether you're a capital E engineer that does this for a living and you love it and you do it as a profession, or you're the lowercase e engineer, and I agree, Michael, amateur is a harsh word that we tend to like underappreciate. So I'm gonna not even stay away from that. That's a lowercase e engineer to me. But I want to talk about that intrinsic motivation that I think we all have, that excitement that we have about hardware. So just want to go around the room again and hear a little bit about like what keeps you here, what brought you to hardware, why do you stay for it? Maybe let's go back in reverse order this time. Let's start with Michael. Why hardware? Why do you stay here? I mean, you work in software now. What's the excitement about hardware and making?
Yeah, so some of my transition to software was a bit dictated by research. It was in my field, it was a little difficult to, build something really cool and then put it out in a research paper. It usually needed some sort of algorithm or software component to it. So that kind of defined my current career trajectory. No regrets about it. But there are two main things that keep me coming back to hardware. One is I feel like creating is a cure for consuming things. So like all these little shelves that I have on my pegboard here, they're all just 3D printed and I don't have to buy them anymore. Or if I see this little doohickey for the kitchen in Walmart or something, I can just think, oh, I can just print this at home. And I usually never do, but it keeps like one less thing cluttering my house. So that's one aspect. The other aspect is just physicality. There's really no replacement for these things in the real world. Software is just data. You can do many things in software, and I think maybe too many things. And looking at making from a creative perspective, it's kind of this physical constraint. You have to work against physics, and it's this puzzle that you have to solve. And in making, I just like the idea of mastering something physical. There's like a satisfaction that you can only get from something tangible, whether it be an athlete working on a sport or a musician playing an instrument or makers using tools that they use to make.
I love that. Creating is a cure for consuming. I think I'm going to save that one. Keep that in my back pocket. Let's flip over. Cara, I'm going to ask you the same question. Why hardware? Why do you stay?
Yeah, actually, I'm trying to think when it was for me that I knew hardware was something that I really liked. So I think if I were to go back to it, I was doing a lot of things with circuits. I was a biomedical engineering undergrad, but it was out of the electrical and computer engineering department. So I was doing, theory for circuitry and electronics and signal processing. And then finally I got to the stage where I got to build everything. And I got to build an EKG, like literally build the entirety of it, program everything in, like to take everything that I was learning and actually like build it. And it was something that I knew, and I knew that other people, I just felt so satisfied. And I think going from that stage to then, I was an undergrad right at the boom of Fitbit and all these, watch-based technologies. I think the first Apple Watch came out back then. And so I actually built a PPG sensor, like basically a, undergrad version of a Fitbit. And the fact that I could take each individual component and actually build this myself was just so exciting to me. And again, I still, I had to use all the theory and all the different things that I had learned, but the act of like putting it together, maybe it was therapeutic, sort of Micah was saying, or I just gained this sense of satisfaction of like, I can use this knowledge that's in my head to create something, and something that has a connection to people. I think for me, in my research area as well, almost everything that I do has some connection to make things better for people. And so I think being able to do that has sort of not only just brought me into this field, but kept me here, that we can keep iterating and building more and more things that are going to help make human life better, and make things easier for people. And so I think, yeah, I just love it, and I can't wait to keep doing more.
Last but certainly not least, Nathan, why hardware? Why do you stay?
For me, it's the day that I learned that I could control the physical world was the day I got hooked, right? So the idea that I could blink an LED, whoa, that was fun. And then I could control a servo was like, oh, wait, I can manipulate stuff around me. Fast forward a handful of years, and I was hanging out with my niece. I think she was 7 or 8 at the time. And she knew that I was into this weird electronic stuff. I was like, well, what do you want to build? How do you want to control the world around you? Like, what is something you're interested in? And she was like, oh, I want to build a box that shoots glitter in my dad's face. And I was like, yeah, this is my brother. And I'm like, absolutely, we can do this. And so with a motion sensor and, a little spray can and a servo pushing down on the button, we could spray glitter across this thing and shoot it into my brother's face. And it was so awesome to, have a kid get inspired to learn about all the pieces to make that happen. It can just, the idea that we can move from the screen and writing code and writing compile and to the physicality of the world is really what keeps me going every day.
Great. So I want to go off script here a little bit because we had another question from the audience that I thought was really interesting, and just want to maybe in our last couple of minutes bounce this around. Can you teach making? Is making a self-taught experience? Can you be a maker through formal education, or is that a different element? So I kind of want to just bounce that around, and maybe let's start with Michael again, but maybe from your own experience, were you self-taught? And then how do you feel about making in general?
Yeah, I'd say, I don't know if self-teaching is a thing, because you're still using resources that someone else created. So I got an Arduino from, he's actually a Cornell alum, Steve Blum. He was the first set of Arduino tutorials on YouTube back when I was starting out. And yeah, just using that as a resource. But I come from a line of engineers. My dad is a real gearhead, so working on cars with him was really useful to see the physical world working. But I think self-teaching, it kind of reminds me of how some artists or some writers or other professions, they don't have to have a degree in it in the same way that you don't need to be an engineer. I know a lot of great makers who are artists or something totally different than engineering by training, but they just know how to make. So I think, yeah, if you have the drive, that's all you need to be a maker, in my opinion.
Great. Bounce that to you, Cara. Self-taught, or people teaching making? Can you teach making?
Yeah, I think both. I think you can certainly be self-taught, especially if you have that drive and that excitement. Like, I think especially now there's so many resources where like you can take what we sort of were saying as a fundamental maker is really more like creativity and that like actually creating things, and you can supplement that with you know, maybe more theoretical knowledge because we have access to all these resources. But I will say from the other side, I do think that you can be taught how to make, and I say that just because I wouldn't necessarily describe myself as a maker as a kid. It's not that I didn't, you know, didn't like it or wouldn't have enjoyed. I just didn't really know, and I didn't really. It wasn't something that like I had this driving passion for. I need to go and do this. But I feel like through formal education, I have learned to think like a maker. So I guess like, you know, it's sort of an answer, non-answer that yes, you can learn it, but also you don't have to have the formal training. It's sort of like sometimes people don't know where to start, and thankfully we have lots of great people like the people here on this panel and Deanna who want to give resources so that people have access to it, so you can learn how to be a maker. But yeah, sorry, this was not the most well thought out answer, but I think hopefully the core of it is that like anyone anywhere I think can be a maker, and if they need a little bit of help and support, they can definitely get there, and if they don't have that but they're really excited and self-motivated, I think they can get there too.
Anyone anywhere with the Cornell Big Red behind you.
Anyone anywhere, exactly.
What we do here. Nathan, close us out. Self-teaching versus formal teaching on making.
Well, I liked Cara's answer a lot. And I think every person could have the opportunity. It's whether or not an educator gave them that or exposed them to that opportunity. So I feel like anybody could get excited about their own thing, but it took a moment. I think we all had a series of moments in our life where we were exposed. So, for example, my mom brought home an old computer that was in the trash, and I spent a week just taking it apart. And that was sort of this transformative moment where I was like, oh, wow, it's not just magic inside the box. But I had the fortune of that opportunity. How can educators give other children, everybody in the world, whether it's electronics or hardware or cooking or, you know, that experience where you get excited about a thing. And once you're excited about a thing, that's what gets you through Calc 2. Right? It's whenever we have to take Calc 1, Calc 2, physics, but all this stuff, these extremely theory tripping, heavy, not so great classes. But what I clung to was those really fun experiences that showed me that I was a maker. And so, sure, I'll get through the drudgery, and to play to Cara's answer, you know, we have that formal teaching to kind of set us in the right direction. I know I have to go through that, but at the end is where the fun is going to be. And so I think anybody can be a maker. It's just up to society to give that child the opportunity to be exposed to the thing that makes them tick, so that it can hopefully set them in a path to where they can be ultimately successful.
Great. Well, we are coming up very quickly on the end of our hour, so I want to take a second here to thank you all. I really appreciate the conversation. I've been looking forward to this for a while and loved hearing your different perspectives on making to manufacturing, scalability. How can that garage builder go pro? How can they really advance their own level as well as maybe advance their product if they have a product they're looking to advance? And on that note, I will just drop a quick note that our prototyping program here at Cornell, so our program run out of Rev downtown, is accepting applications. So if you are that person who has an idea, want to figure out if it's scalable, if it has a market, you want to get into making and starting to build this out, we have a program for you. You need a napkin sketch, an idea of a customer, and we'll take you from there. So applications are open. We'll share the link from this here, and we hope to see some applications coming in the future. But thank you all. Really appreciate your time today, and we'll be in touch. Have a great rest of your Wednesday.